we're going to talk about how to solve absolute value inequalities. So let's get right into it. Let's say if we have the absolute value of 2x plus 5 and it's greater than 11. So quick and simple, how can we solve this? What I recommend doing is to write two equations or two inequalities. The first one is going to look exactly the way you see it without the absolute value symbol. The second one, here's what you need to do. Rewrite the stuff inside of the absolute value equation, change the direction of the inequality, and change the sign of the number that you're dealing with. So instead of 11, we're going to have negative 11. Now, whenever you have a greater than symbol, this is going to be an or expression. If there's a less than symbol, this will be an and expression. And you'll see that throughout the problems that are coming up. But now let's go ahead and finish this problem. So let's solve the inequality on the left by subtracting both sides by 5. 11 minus 5 is 6. Next, let's divide both sides by 2. 6 divided by 2 is 3. So our first answer is x is greater than 3. Now, let's get the second answer. So once again, we're going to subtract both sides by 5. Negative 11 minus 5 is negative 16. And then we're going to divide both sides by 2. Negative 16 divided by 2 is negative 8. So x is less than negative 8. And if you want to, you can check your answers. For instance, if we pick a number that's greater than 3, will this equation be true or false? Let's say if we plug in 4. This would be 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 is 13. And the absolute value of 13 is 13. So 13 is indeed greater than 11. That works. So what if we plug in a number less than negative 8? Let's say negative 9. Will this be a true statement? 2 times negative 9 is negative 18. And negative 18 plus 5 is negative 13. The absolute value of negative 13 is positive 13. And so that is a true statement. So we can see why these answers are indeed correct. But that's how you can check your work if you want to. Now let's talk about how we can graph this on a number line. So let's say this is 0, 3, and negative 8. So we have x is greater than 3 but not equal to it. So we're going to draw a line to the right. And because it's not equal to 3, we're going to use an open circle. Now for this one, x is less than negative 8. Because it's less than, we're going to draw the arrow to the left. All the way to the left, we have negative infinity. And all the way to the right, we have positive infinity. So now we can represent our solution using interval notation. So x could be anywhere between negative infinity to negative 8, as we see here. And then union, it could be anything between positive 3 and infinity. With infinity symbols, always use parentheses. If you have an open circle, you also need to use parentheses. If you're dealing with closed circles, then you need to use brackets. Now let's try another problem. So let's say we have 3x minus 4. And let's say this is, instead of greater than, we're going to say it's less than 17. Let's say less than or equal to 17. Go ahead and try this problem. So let's write two equations, or two inequalities. So the first one is going to look exactly like the original without the absolute value symbol. Now, because it's less than, we're going to have the word and instead of or. If it was greater than, we would have the or situation. Now for the next one, we're going to rewrite what we see inside the absolute value equation or symbol. And then we're going to change the inequality. And then we're going to change 17 to negative 17. And then all we need to do is solve these two inequalities. So let's begin by adding 4 to both sides. 17 plus 4 is 21. Next, let's divide both sides by 3. 21 divided by 3 is 7. So we get our first answer, x is less than or equal to 7. Now let's get the second answer. So let's add 4 to both sides. Negative 17 plus 4, that's going to be negative 13. Next, let's divide both sides by 3. And so we get x is greater than or equal to negative 13 over 3. Now let's go ahead and plot what we have. So let's draw a number line. 7 is going to be on the right side. Negative 13 over 3, that's somewhere to the left. Negative 12 over 3 is negative 4. Negative 13 over 3, that's like negative 4.33. Now let's plot this one first. So x is less than or equal to 7. Because it's less than, we're going to shade to the left. And because it can equal 7, we're going to use a closed circle as opposed to an open circle. Now here, x is greater than negative 13 over 3 and equal to it, or equal to it. So we're going to use the closed circle as well, but because it can be greater than negative 13 over 3, we're going to shade to the right. So notice that our answer is between these two numbers. So we could say that x is less than or equal to 7 and it's greater than or equal to negative 13 over 3. So we can write a compound inequality to represent the solution. Now let's talk about some trap questions that you need to be aware of. Let's say we have the absolute value of 3x plus 5, and let's say that it's less than negative 3. What is the solution to this particular problem? The solution. Now let's talk about some trap questions that you need to be aware of. Let's say we have the absolute value of 3x plus 5, and let's say that it's less than negative 3. What is the solution to this particular problem? So I want you to think about it. Feel free to pause the video and try this problem. Now, the absolute value of a number can never be a negative number. So we can only get 0 or a positive number. Is 0 less than negative 3? What would you say? 0 is not less than negative 3. It is greater than negative 3. Because if you draw a number line, 0 will be to the right of negative 3. The numbers that are greater are on the right of the number line, and the numbers that are less are on the left of a number line. Now, what if we pick a positive number, like 4? Is 4 less than negative 3? 4 is to the right of negative 3, so it is not less than negative 3. Therefore, no matter what value of x you plug into this expression, this will not be a true expression. So therefore, there's no possible solution. Therefore, you could write no solution as the answer to this problem. Now, let's look at another example. So let's say if we have the absolute value of 4x minus 3, is greater than -4. What is the solution for this particular math problem? Now, let's look at the possibilities. So this could equal 0. Is 0 greater than -4? Drawn a number line. 0 is to the right of -4. So this is possible. Now, let's say if we get a positive number like 8. Is 8 greater than -4? 8 is also to the right of -4, so yes. So any positive number that we select will all be greater than -4. So every value of x that you can plug in, this will always be true for any value of x. If you plug it into this expression, it will always be greater than -4. You could try looking for a value of x that doesn't work. You're not going to find it. So therefore, we could say that x can be all real numbers. To write that as using interval notation, you could say it's -infinity to infinity. And on a number line, basically you're shading the whole thing. X could be anything. So you could say all real numbers or all solution. Now let's work on one more example problem. This one is going to be longer than the other ones. And this problem is going to teach you one key lesson about solving absolute value inequalities. And here's the question. Should we write two expressions now or later? Notice that we have numbers that are outside of the absolute value expression. So in this case, until you get rid of those numbers, you do not want to write two inequalities. You need to get rid of those numbers on the left side. Until you get the absolute value expression by itself on one side of the inequality, then you can write two expressions. So the first thing we're going to do is subtract both sides by 5. "17 minus 5 is 12. Next, we're going to divide both sides by 3. 12 divided by 3 is 4. Now, notice that I do not have any numbers outside of the absolute value symbol in this inequality. Now, it is at this point I can separate it into two inequalities. The original one, and then the second one, I'm going to reverse the inequality symbol and change the sign from positive to negative. Now, is this an or situation or is this an and situation? Because we have the greater than symbol, it's going to be the or situation. Now let's go ahead and solve each inequality. So let's begin by adding 4 to both sides. And so we're going to have 7x is greater than 8, and then we could divide both sides by 7. So our first answer is x is greater than 8/7. For the next one, we're going to add 4. And so we have 7x is less than 0. And then we could divide by 7. 0 divided by 7 is 0. So the other answer is x is less than 0. So now let's plot this on a number line. 8 over 7, that's a little bit more than 1. So x is less than 0. We could shade that to the left, or is greater than 8 over 7, so we're going to shade that to the right. Don't forget to put your infinity symbols. So the solution is going to be negative infinity to 0, union 8 over 7 to infinity. So that's basically it for this video. If